All right, I'm back. I'm working on a 2017 Chrysler Pacifica with the 3.6 V6 engine. Issue with this one is a history on it. Back in August of 2019, the car was taken to a local dealer in Mountain Home, Idaho. They've had it since August several times. They cannot figure out what's wrong. They're throwing parts at it. Well, the issue is the CAN bus communication is what we found out. So I did a full system scan with the MS906BT Bluetooth Yatel. If you look here, there's a bunch of codes in all these modules. So I'm gonna hit report just to show you kind of what's going on. There's 13 codes in the PCM, 4 in the TCM, 8 in the ABS, 1 in the airbag, 2 in the BCM. I'm not going to read all these. There's just a bunch of codes. Well, if you look at all the codes, they're all U codes, and U codes are communication codes. Invalid data, implausible data, lost messages, CAN C bus, all that. So what Chrysler uses on these is a star connector. And there's like 3 or 4 star connectors for different bus communications on this one, but this one specifically the CAN C bus, which is the CAN C bus, which is the high-speed bus system. Your engine computer, tranny computer. And if you look over there, there's an electronic shift module. So it's not your mechanical shifter, it's an electronic shift module. Well, the problem is when this thing loses communication, it won't let you shift. It may shift in the neutral. It's got electronic power steering. All these systems go out. They don't know what's going on with it. The computer doesn't. So I'm going to go to my oscilloscope here, and if you look down here, I got my breakout box hooked up to the OBD port. I have my dongle hooked up for my scan tool, but my oscilloscope's hooked up. I got my grounds piggybacked on pins 4, which is chassis ground. You could go to pin 5, signal ground. And I got CAN high and CAN low, which is on pin 6 and 14. Pin 14 is CAN low, pin 6 is CAN high. So I'm going to hit play here. This is live data because I got the key on engine off, and right now it's actually doing it. So if you look here, if I hit stop, these messages, or these are zeros and ones in here from the computer, basically telling it, you know, turn on fuel injector, turn off fuel injector, or whatever it may be. But the sawtooth pattern up here, that's bad. That should be at 2.5 volts on both of these. Well, if you look, it's at like 3.5 on the peaks there. It's not supposed to be like that because that's a corrupt message. It's a bad bus. So if you stay watching that, and you can hear the instrument panel doing all kinds of weird stuff. I'm going to go to the other side of the star connector and see if I can wiggle the wires, because it is a pin retention thing, and see if it goes away. So I'm under the instrument, or under the glove box. Just going to wiggle these wires. Just got to get it to go away now. And we did notice it's worse when it's hot, sometimes cold, depending on pin retention. Yeah, I just had it. You seen it go away there a little bit. And move it to the right spot. You just got to wiggle the wires. So right there, it's good. Well, if you look, the bias voltage is 2.5 volts on each one. So that means bias voltage means don't do nothing. It's good to go. Then you can see your packets of information. Well, if I move it a little bit, sometimes it'll come back because it's all loose pins. Right there, it's bad again. And it's good again because I moved it. I let go. So it's good right there. Bad. Good. Imagine hitting bumps going down the road. Right there, it's bad the whole time. The computer knows that it's not correct. Well, it's trying to use that information, but it's corrupt. So it cannot use that. What it all boils down to is pin retention on the star connector. So I'll show you exactly where that star connector's at we're having issues with. So you can see the engine lights on. Look at the tachometer. It just moved up and down because it's, well, corrupt still. It's instrument panels chiming all kinds of stuff. The electronic shifter will go out. It'll shift into neutral sometimes. The longer it's corrupt, the more issues it'll have. This specific star connector is under the glove box. I'm going to try to get under to show you. Let me see here. There's the star connector right there. It's where all the CAN high and CAN low data lines meet on the star connector. And yes, I checked across pins in 6 and 14 on the breakout box and all that, and I got 60 ohms because they run 220 ohms resistors in parallel and you get 60, so it's all good. The issue is those loose pins, pin retention in the star connector. How would it fix it? I'd definitely get a new star connector, like 50 bucks I think they are, and new connectors on the end of female pins, and they're like 5-10 cents at Mauser.com. And that's what's causing this whole entire issue, that the dealer could not find out. They kept throwing parts on it because of I guess they're doing two main things wrong. Is they're not troubleshooting correctly, using the oscilloscope instead of, they're using a multimeter, and you can't use that because that just averages them, the voltages. And the other thing is they're not reproducing the same condition, just like we did here. Alrighty, I just wanted to show you guys the actual star connector. This is a brand new one. It's like 50 bucks. There's 2 pins in each one. That's the CAN high, CAN low. This one has 3 pins because it's a ground, the main ground for this CAN bus system. And the male pins are in all these. If you flip it over, there's a few resistors, a capacitor, and some ferrites on each CAN high, CAN low to cancel out noise. This little black box here, basically this star connector snaps in here, and you put it into the vehicle under the glove box, and it holds it in there securely. These right here, these little white pieces here, these are where the actual female connectors go. These aren't bad, but I bought them anyway since they're so cheap. And then these right here are the actual connectors that were bad. These are the female connectors there that are actually bad. Not all of them, but basically they slide into the white piece there. Whoop. And then if you look here, if I put this in here, I got good pin retention there. Like, I'm pulling pretty good on it, and it's not wanting to come out. There it does. But the old ones, like 3 or 4 of them, would just slide right out. So obviously what I would do is I cut the wires, crimp the new connectors on, put them in the new containers there, or the new connector part, and then basically these just slide in there, and that would fix it. Now, I did order all these parts except the star connector. I had to get the star connector from the dealer. But all these parts I got from Mauser.com. There's the part number for each one. I know I told you they were 5 or 6 cents a piece, but they're like 36 and 29. $8 shipping, so I spent like 18 bucks, but still cheap. This is the blueprint. Not that really matters, for the actual connector here. That's the blueprint for that, or the data sheet, I guess you'd call it. And then this one right here is the data sheet for the actual star connector itself. And then who makes all this stuff is TE Connectivity. Chrysler doesn't make it, they contract it out. TE Connectivity makes it. So, like I said, I would get a new star connector, cut the wires, crimp the new connectors on, put them in the container here, the holder, slap it back together, and that'll fix the problem.